All right. Good morning, chemistry students. I hope y'all are having a blessed and fantastic day. So wonderful morning, wonderful Monday morning. All right, we're going to be talking about the ideal gas law. I'm not entirely sure if we talked about this already. If we have, fantastic. This will be a review. If we haven't, I tried to make this as clear and concise as possible so you guys can understand exactly what I have to teach you guys. And I've also prepared two example problems that we can do. So with that being said, here we go. Let's go ahead and knock this out. All right, so really quick, this is the ideal gas law. Okay, it is PV equals nRT. PV equals nRT. It's a little easy for me to remember because PV. Okay, anyway. All right, so pressure is P, volume is V, N is moles, R is ideal gas constant, which is 8.31. It will always be that. It will never be nothing else. Just like Avogadro's number is always 6.02 times 10 to the 23rd power, right? It is never nothing different. And temperature, which is measured in Kelvin. That's what the K is for. Okay? So those are the units that's right bomb in the parentheses. Make sure you put units. R does have units, but for the sake of simplicity, I'm not going to include them as it is very ridiculous. So don't worry about it. Okay? I never asked you to put those because you'll never have to calculate R. R will always be that number, so there's nothing to calculate. Okay, so before we get started, things to know. Okay, it's only three of them. Number one, temperature is always measured in Kelvin, meaning that if you already have Celsius, some problems will give you Celsius and not Kelvin. If you already have Celsius, you must convert it into Kelvin, and it's very easy to do. It's whatever your number is for Celsius plus 273. Boom. So, for example, if Celsius was 30, 30 plus 273 is 303. That's what K is. Okay? Very simple. All right. As I said earlier, R is always equal to 8.31 every time. Like, don't put another number for R. It's always that. And then number three, pressure can be measured in ATM, atmospheric pressure, kPa, kilopascals, or mmHg, which is millimeters of mercury. Mind you, Hg is mercury, not Mg. That's magnesium. Okay, so millimeters of mercury. All right, and here's the conversion factor just in case they don't give you ATM or atmospheric pressure and they give you something else. They give you millimeters of mercury, 760 is equal to 1. And if they give you kilopascals, 101.3 is equal to 1 ATM or 760 mmg. All these numbers are equal to each other just in case you need them. But I don't think you guys will, at least not now. Okay, now to the nitty gritty. Steps to solve an ideal gas law problem. Okay, so here are the steps if you wanted to take a picture of them real quick or whatever. And I'm going to leave it here for a quick second. Woo, that's that Rona. I'm just playing. All right, so anyway. All right, so I got some example problems for you guys right here. We're going to roll through them together. All right. Just to make it easy to identify, I color coded them for you. I color coded the components for you. Okay. This is what your problems will look like. Okay. Now, for the record, for every problem, they're only going to give you three variables. Just three. They will never ever give you R because we already know what R is. Okay. It's 8.31. It is always that. So they'll never give it to you. That don't mean you don't use it. That don't mean you do not use it. Okay. So number one says, how many moles of gas does it take to occupy 120 liters at a pressure of 2.3 atm and a temperature of 340 K? That's the question, right? Cool. So really quick, very, very simple. Obviously, it said how many moles. Moles is in. Okay, so this is in. And step number one, I'm coming up here, says identify the letter they want you to find. Well, we just did that. They want us to find N, right? Cool. That one's easy. All right. Step number two, get the letter they want you to find by itself, meaning no other letters are on that side with it. Okay. Do this by dividing every letter on the side on the side with it by itself and move it to another side move it to the other side of the equal sign. So real quick, let me explain what that means. It's very, very simple. Okay. You got two sides. of the equal sign. You got the left side, you got the right side, right? I just drew a line just so you can see the sides. Okay, the left side has P and V, right side has NRT. The one that we want by itself is N. We don't want to move that. So we're going to move everything else on this side that is not N to the other side. In this case, R and T gotta go, right? In order to do that, since all three of these are being multiplied together, all we got to do is literally divide everything on this side that's not N, which is R and T. So we're going to divide these. So we're going to do that. Okay. And they're going to cancel out on this side. But remember, what you do to one side, you do to the other. Right? Okay. And that's going to give us this formula. All right. For the sake of, no, actually, no, I'm just going to write it like that. So I don't want nobody getting confused. All right. So I'll just write it like this. So N is equal to PV over RT. That's what N is equal to. All we did was just divide these to get rid of them and just move them to the other side. Nothing is not hard. Very, very easy. Okay. Number 3, put in the numbers that they gave you. Well, we got our formula now, so now we can put in our numbers. So let's do that. Okay. I'm actually going to rewrite this the other way around. It's the same exact formula. I'm just writing it the way that you would normally see it. So N equals PV RT. Okay, it's like same thing. It's nothing different. All right, now let's put in the numbers. So real quick. So N is equal to, they gave us a pressure. Okay, our pressure was 2.3. Let's put that in. 2.3 needs to be multiplied together. So yay. All right, they gave us 120 for the volume. Okay. Mind you, you know exactly what they gave you because you know the units. Pressure is ATM, volume is liters. So that's how I know what they are. Okay. Oh, they didn't give me R, but you know what? It's cool. I already know what it is. 8.31, right? 8.31. And then they gave us a T, and it is in Kelvin, thank God. So it's 340. Cool, cool, cool. All right. And then we're going to do some math. So let's go to our calculator. All right, come on, calculator. All right, and let's do the math real quick. We're just going to put the numbers in exactly the way we have them. So 2.3 times 120. So let's put that in. So 2.3 times 120. And we get an answer, which is 276. So I'm going to write 276. I guess I just do it down here. So 276, that's the top answer. Cool, then we got 8.31 times 340. So let's do that. So 8 point, hold on, let me clear everything. All right, so 8.31 times 340. I'm going slow on purpose just so you guys don't get confused. All right, so 2825.4. All right, so 2825.4. Okay, and now we're going to do is just divide this by this and we'll get our answer. Okay, mind you, I said divide the top by the bottom. So we're not going to put this divided by 200 whatever because that's not the right way. Okay, we are going to put the way it looks, 276, boom, 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 divided by 2825.4. And that's our answer. We're gonna round it to 2 decimal places. All right. So this is actually gonna round that 9 up to a 1, well, a 0, which will round that up to a 1. So the answer is actually gonna be 0.1. So 0.10. And we were looking for moles, so our units is moles. Boom, easy peasy. All right. Then we come to the second problem. Now, actually going to roll through this insanely fast. All right, so here we go. A student is doing an experiment where he has a gas that is heated to 133 K. So we know that our temperature is 133. Cool. At a pressure of 25 atm. So that means pressure is 25. And if he has 22 moles, so they giving us all this of a gas, what's the volume? Okay, we don't know V. All right, so they want us to find V. It's the one they want. So just like step one actually says, I'll go back to it so you can see it. Step one says identify the one it wants to find. We did that. Get the letter that you want by itself. So we're gonna do that. Okay. Remember, all you gotta do is go to that side, which V is on the left side now. Anything that is not V on that side that is on, we're gonna move it to the other side. You do that by dividing. So we're gonna divide both sides by P, because that's the only thing over here besides V, so that can cancel out, and we move it over here. So now our formula is V equals nRT divided by P. Cool. And at this point, we just put in the numbers that they gave us. So V is equal to N, which is 22. All right, I put in parentheses because they're always multiplied. R is 8.31. It's always 8.31. It would never be anything else. T is 133. All right, and all that's going to be divided by P at the bottom. I know I'm writing kind of sloppy. I'm only using one hand. Okay, all right, and we put that in the calculator. Boom, boom, boom. Let's do that real fast. Come on, man. All right, there we go. All right, so let's do that real quick. Very, very easy. All right, so we got 22 times 8.31 times 133 equals that. Okay, and that's going to be, for the sake of time, because I can actually do this because there's only one thing on the bottom, which is 25. I'm just going to divide whatever this answer is by 25, and that will get me my final answer. Okay, which is 972.60. Yeah. And we were looking for volume, so that the units is liters. And that's how you do an ideal gas law problem. Please do the work assigned to you and have a good day. Bye.